We turn now to the fundamental theorem of calculus. And if you're following along in the Thomas textbook, this corresponds to section 5.4. I'll pause to note that if you're ever taking a course and something is called the fundamental theorem of name of the course, it's probably something that you should know. It turns out that we're really doubly blessed here because there are actually two parts of the fundamental theorem of calculus. Not to be difficult, but I'm going to do part two first. The reason for this is we've used several textbooks here in the time that I've been here, and every other textbook has called the part that I'm about to do part one, and then gone on to part two later. So to me, that presentation just seems sort of more natural. So although our textbook refers to the part that I'm about to do as part two, I'm going to do it first. So we will get back to part one later. Okay. So here is the statement of the fundamental theorem of calculus, part two. So let's suppose that capital F of x is an antiderivative of lowercase f of x. So capital F and lowercase f are different functions, but capital F is an antiderivative of lowercase f. And this is true. This is true for all x in the interval a b. Then, drum roll please, we can state that the definite integral from a to b of f of x dx is equal to, of lowercase f of x dx, is equal to capital F of b minus capital F of a. This is a theorem that's remarkable. It's as remarkable as it is easy to miss. After all, we've already used the integral symbol to mean indefinite integral. In other words, find the entire family of antiderivatives. So you might wonder, what's the big deal here? Recall from the last section that we actually defined the definite integral in this way. In other words, we said that we have this sort of horrendous limit as the norm of the partition approaches zero of this summation. In other words, it's the limit of adding up all the rectangles as the rectangles themselves become infinitely skinny, or equivalently as there become infinitely many rectangles. That's the actual definition of what the definite integral from a to b of f of x dx is. But then we have this theorem that says that we can evaluate this limit in this incredibly simple way. All we have to do is find an antiderivative of the function, evaluate it at the two endpoints of the interval, and subtract. So this absolutely horrendous limit that is very complicated even to understand what it means, it turns out to be one of the simplest limits of all to evaluate, and that's what the fundamental theorem of calculus part one is actually about.